in this session we are ready to design a helix antenna which is belongs to this tutorial, and from here we are ready to design this. And when there is a fundamental given in this design, and in the time of designing there is some turning, operating frequency or optimum frequency. You can see this frequency range is 1600 megahertz, and in the time of being design an antenna, we can sometimes we need to we need the operating frequency of 2450 megahertz. So you can design it both parameter in designing of this geometry builder, or you can changing the value of geometry. You can build this type of antenna designing of helix, so to create a design. So we are ready to design this at 1600 megahertz frequency in the grounding, and in the grounding. So in the time of design, we at first we have to we are given in this type of parameter, and to designing the helical antenna we have to design. So here you have see there is some command is given in the editor window, and it is perfectly called that means that helix over the perfect ground. Helix starts at ground. Helix excitation at the first segment of helix. There is some value where it indicates some portions. You can see there is a segmentation of the symbol is called GH. It means the geometry of helix, where the 1 is the number of tag and 120 is the number of segment of this wire. So here you can see the value of 0.04648. Here the value is the spacing between the value is the spacing between the winding or the coil. Helical antenna look like this type, which is a looping antenna. You can see it's a directional antenna. So the value indicates 0.04684 is the spacing between the loops, and 0.23442 it means the total length of the antenna wire, the total loop length. You can see that as a loop length of total wire, or the length to looping this antenna as this type of turn. So when you see the next value is when you see the next value 0.02982, it means the radius of the bottom side of this antenna, and in x1 direction, or the side of x-axis, and the value of 0.02982, it means the value of y2, which the radius of the bottom axis in y direction, and the next value is the directional value of x2 radius, which is directed at the top of the antenna loop, and the final value of this same pattern parameter is 0.02982, which means the same value, which means the radius of y direction, radius of the wire in y direction at the top side of this antenna, and the last value of 0.001, it indicates the radius of this wire, antenna wire. GE remains geometry, GE means the end of this geometry, and GN, which is showing the value of 1, it indicates it is perfectly grounded. The helical antenna is set up in a ground, and it works in perfect ground condition. Then the ek, which ek, it showing there is none of value, but it should be when the time of geometry command, the other portion, the kernel of geometry, extended kernel, it means extended kernel, will be ticked in the command of ex, which is the abbreviation of excitation. From here you can see the sources option. 0 means the voltage source, and 1, which is the number of tag, and the segmentation is 1. From here it indicates, and the 0 from this is the number of tag, and there is the 1, which is the magnitude of the real part of the voltage, and the 0, which is indicates the imaginary part of this voltage source, and this one is the phase voltage, which is the magnitude form in 1, and the 0 is the phase imaginary part, phase angle, or the imaginary part. Then the frequency response, or frequency sweep, there is the value of 000 and 1600 megahertz. Here it indicates all of the value in different position, but in the geometry edit window you have only the fulfill to the or set the frequency, which is at 1600 megahertz, and the last command of int. You can see the abbreviation of all the parameter of GS is given here. You can see it as a GS, the geometry of helix, which is the tag number of 1 segments, and there the total segments, and the spacing between the windings, where is 0.04684, and the total length, which is 0.2342, total length of the wire to loop this antenna. And here is the radius of the bottom part, and the y1 of the bottom part, y1 radius. It means x1 means the in the x direction, positive x direction, and y1 means the positive y direction. In both side, there is two side of this axis, one is positive or one is negative, but this time we are taking the total value is in positive direction. It means the value of the positive direction, the level or layer or loop of this antenna will be over the ground, but it starting from the ground position. The radius of this total wire is taken in 0.001. So if we want to take this value, so at first we have to open this geometry tab and put the file clear and take it a new, and then you have to fulfill this according to the given value. You can see here the below of this window it's GS, which means the geometry of helix. To take this helix, you have to press this button and select this helix. It means you are on the mode of geometry of helix. Now press the tag on the 1, or the wire number is 1, and the segmentation is 120, and the spacing of this loopical loops is 0.04684, and the length of the total is 0.2342, and the radius of the bottom side in x1 direction, which indicates one of the means the other direction of this antenna, which is x1 and x2 is opposite, but they are in the same side. The positive symbol, the positive value means that they are in the same side, but the x1 and x2 means they are in different position or opposite position. So when you take the value of radius of x1 on the bottom side, you have you are showing that 0.02982, 0.02982. All the values of x1 and y1 and x2 and y2 are same, 0.02982 and 0.02982, 0.02982. 0.02982 and the wire radius is 0.001. You can take it as your one requirement. At the now you are in the portion of source and load. In the time of load section, there is no load indication in this segment, so we are tick off this portion and we are only put the value of source. So in the excitation of the table, we are ready to take the excitation, which 0 indicates the voltage source, and the tag, which indicates the number of wire, it is 1, and the segmentation is 1, and the optional is 0, and the real part of this value is 1, and the imaginary part of this value is 0. So after taking this, we go to the frequency section, and you can see the frequency range is 1600 megahertz. So we are taking it 1600, and it's shown in it's you see the GN ground portion, which indicates the 1. It means it is in perfect ground condition. Perfect ground condition, you should check the tick mark on this button or the segment. Then you have to run this segment. You have to, at first you have to save this file as your name. I named it for helical or helical helix helical I'm saying that for helix antenna TNNA. So after saving that, you have to put the tap on the run command and set the far field pattern at 1600 megahertz, and you have to put this value and generate to see the radiation pattern. You can see the radiation pattern, which is the same as the far field simulation. If you want to see the radiation pattern, it's in vertical plane. So if you see it, want to see it in horizontal plane, then you have to press the space button, or in the far field pattern you have to see tap on this vertical plane, then you have to see the vertical plane, and when you have to unmark this button, then you have to see the horizontal plane, and in the vertical plane you can see the maximum gain or the phase angle. So after seeing that, if you want to here the design is ready, but the parameter is so high, so the antenna is not showing here. To showing this antenna, we are opening the 3D window and see this parameter as the generate of this window, and when we are showing the multicolor pattern, the radiation parameter is showing in the blue portion, which the radiation pattern indicates that the radiation is nil at this side, at this ground side. When you go to the top side of this antenna, you can see the violet portion, which indicates that the maximum radiation happens in this part. So after going through this, you have to already seen this type of antenna and the radiation pattern. You can see it in various field. If you can see, if you want to see the near field pattern, then you can see the near field pattern where the radiation of this violet zone is maximum, and the other portion is tremendously decreasing when the pattern is going downward or other opposite side of this portion. You can realize it using this visualization level of this portion of color code. So And finally, when you want to sweep this portion at this frequency sweep option, then go to the frequency sweep and resolution is 5 degree, and I want to see I want to simulate this for 1600 megahertz. So I can used to I'm setting this value of 1350, and this value is for 1450 for the step size of 1 and the theta. So I want to wait this type this output. When you can see this at 1600 megahertz. Sorry, where the frequency range is wrong. We have to put this value at 1550 to 1650. When you increase the value of this starting and ending frequency range, suppose you have taken the frequency range 1300 to 1700, then you have to increase the step size, otherwise you cannot generate this frequency range of frequency range radiation pattern. It must be very careful to seeing your radiation pattern. So putting this value, you can generate this pattern, and here you can see the radiation pattern and the 3D view of this antenna. 3D view of this antenna, you can see there is a voltage source which feed in the center, in the ground point of this value, which is simply which the symbol of the antenna is red, and the frequency of the 600 megahertz, you can see there is the LWR ratio is 2.95296, and the reflection coefficient is that at the gain is a minus 8.37, and the gain increasing in the value of frequency range. And you can see there is the red color which indicates the frequency back of theta is equal to minus 180 to 0 minus 180 to 0, and the rare frequency of the value which indicates the green, which is minus 5.61. So when you indicate this, when you see this value, you can change this at logarithmic scale or normal. It's not a matter of fact, it's your wish or desired. So this is the value of gain, and you can see the impedance at 600 optimum frequency of the impedance, resistance and reactance value. Resistance of this value is 115.881, and the reactance is minus 56.065, and there is the impedance phase, magnitude and phase form of this design parameter of helical antenna. There is the antenna begins, but the value is so much higher, so the antenna cannot be shown in this profile of geometry. So that's it for the geometric antenna. Hope you can understand the parameter or the value of geometrical antenna. So when you see the geometric antenna of this parameter, you can easily set it as your own direction. It's not a problem. And after showing this, you have the antenna design, and there is a new parameter of after the geometry of helix. There is geometry of move, where the geometry of move, where the helix is a lifted version, or the ground connected, but the helix is upper the ground above 5 millimeter above the ground, but they are connected with the antenna. So when you want to design this type of parameter, then you have to put the value in the geometry option, and at the first segment you put the value of geometry of helix, which is this parameter, you can see this parameter, and when you see the geometry of move, then you have to set the value of copy or move and set the value according to. So when you have the geometry move card, then you have to set the geometry move card at copy or move. Then you have to set the value of t or the segment is 130, and the new str which is 1, and the value of root x 0.02982, and then the value of 0 y or z is 0, and the move of x is 0.02982, and then the move y is 0, and the move z is 0.005, and the radius of this will be 0. Sorry, this the I have made a mistake. Yeah, at first you have to set the value is copy of where, then you have the set the move cartridge 0, tag number 0 0 0 0 0 0 0, and then there is 1 2 3 4 5 6 7 0, 1 2 3 4 5 6 7 0, and then the value of 0.005, and the final value is 0. So we are moving the values in z axis according to. Then we have the portion of geometry of wire. This set the wire. Then you have to put the value of tag number is 130, and the value of segment is 1, and the x1 is 0.02982, and the y1 is 0, z1 is 0, and the x2 is 0.02982. Then the y2 value is 0, and the z2 value is 0.005, and the final 0.001, which is the radius of this portion, and the excitation, which is the source and load. At the first we select the source, and the tag, which is tag number is 130. Here is the change, and you have to set the value according to the one, and which is 600 MHz frequency range. We have the frequency at 600 MHz, and the extended kernel is ticked, selected. Then we are run the perfect ground condition, and we see the fulfill pattern at 600 MHz frequency pattern. You can see this, and you can see the 3D pattern where there is a slight change in this shape, which is in the wire in the axis direction at the segmentation of 130. So here sorry for the interruption. I'm repeating this process again. After putting this value according to their sequence, I am simulating at this field pattern, and seeing visualize the commands according to their pattern. Fulfill pattern is generated, then the radiation pattern happens this types, and when you visualize the pattern in 3D, then the design parameters looks like that. And after taking this visualization and happening this, we are simulating the near field pattern to see the radiation in total scale. And here you see the radiation pattern in the violet color in the maximum radiated area, and the light orange, or the a little bit to the yellow or orange, is the less than radiate of the maximum position, indicating the violet portion, and the blue is totally the radiation less area. So when we sweep, when we generate the output of this values at frequency sweep at 1600 megahertz, starting from 1550 to 1650, and step size of 1, and the radiation pattern is generating this frequency sweep looks like this type, and patterns and geometries looks like that. Here you can see a line interrupting, that means there is the radiation here, but the antenna design is in here, but the geometrical value which makes the property of this 3D makes this geometry in the larger scale in shape. So you can see there the sample part of this range is knocking, but already totally is not showing. If you go to the 3D and you can see the proper antenna of this pattern, you can see the radiation pattern which looks like this, and you can see visualize this type. And after that you can see the standing wave 1600 megahertz SWR, which is the standing wave ratio, which is 3.24649, and which is the standard of 50 ohm, and reflection coefficient which is minus 5.5305. So at the 1600 megahertz we can see this radiated values of reflection coefficient. In the portion of gain we are seeing this, the gain is minus 6.56 at the 1600 megahertz, and the radiated portion of frequency back and frequency rear, which is indicating this value. The red indicates the frequency of back portion, and the green is indicating the radiation of frequency in the front side, which means the rear, and the impedance of this frequency, which is indicates the total indicates that one is at 16 megahertz at 152.711 and 36.333 ohm, which is the imaginary part, which is called the reactance, and it is the resistance of this value, and total the Z and phase, which is the form of r theta. Z indicates the in green line, which has the value of 156.974, and minus 13.383 is the angle, phase angle of this the impedance, total impedance. So from this you can visualize that, and after showing that, you can visualize the Smith chart, where you can see there is the frequency at 1550 megahertz, and where the radius of this wire is 0.531, and when you turn the cursor at any point or put the cursor at any point, you can see the value of the phase form or amplitude voltage form, and you can visualize it from here according to their indication. So from here you can easily visualize the helix antenna and their radiation pattern with the impedance and SW curve with their gain according to their frequency range. If you radiate this pattern at 2450 megahertz, then you can find the different type of radiation pattern. You can see it far field radiation pattern. You can see this type of distortion or pattern is happening in this portion, which is totally different from previous. You can say visualize that at the maximum gain of theta is 30 degree. You can see the value, which is 11.1 decibel, which is the maximum radiation of gain. You can see here from the radiated pattern the maximum gain, which is 11.1, and you can see this, there is the maximum radiation value of 30 degree angle, and in 11.1 decibel, and the where the phase or the azimuth angle is 258 degree. you can pressing the horizontal plane or selecting the horizontal vertical to horizontal plane, you can see the radiation button, and by pressing the upward and downward button, you can see the radiation pattern of this shape look like there. And then you can visualize the 3D and go to the structure and selecting the structure and make the pattern in multicolor. You can see the radiation pattern for this frequency range of antenna design, and at the same time you can see the value and the radiation pattern for near field region. You can generating that you have this type of radiation pattern of radiation. And when you try the frequency sweep at this range, then after generating the simulation, you can get same as that same as seems looks like the previous, but it's a little bit different from previous. And if you want to see the Smith chart of this portion, then you can see the radiation pattern of this frequency range and the diameter of wire, which is indicating this type, and reflection coefficient with the range of SWR with the volt ratio and decibel. And then finally you can see the gain and radiation pattern as different formations of this frequency. Sorry, I am missing something. You can see the frequency sweep. I was taking the frequency of 2450, so the frequency range should be 2350 to 2550 at the step size of 1. Then after generating the radiation frequency pattern, we are getting this type of distortion, and this type of distortion where the maximum at the gain of this pattern, you can find the maximum decibel 8.39. This type you can see here from that the 250, the frequency is minus 22.16, the gain is minus 22.4616, which is changed from the 1600 megahertz, and the SWR is also changed, and the reflection coefficient is already changed. And finally when we see the reactance and impedance matching curve, reactance and resistance, the blue line is for resistance and the red line is for reactance. You can see the reactance from here. You can easily evaluate the resonance frequency for this portion. You can see when I go to the left side, there is a portion where the reactance is almost 0.23785. It indicates the frequency of 2422 megahertz. That means that we have the radiation frequency of 2450, and that is the resonance of 2422. So if we want to match this frequency with our optimum frequency, operating frequency, then we have to do the calculate section and start optimization. At first we have to close all the editor window and saving this. Then we have to calculate portion and start optimizer and set that and the default value frequency range to this. And when you start this portion, no variable selected. For this reason you have to set the variable at the portion. To set the variable, what you should do, you should do the length of this parameter, which is L, or the radius of this parameter, which is we can say that we can measure that R, where is the radiation x1, and we can see the radiation pattern of this value. Is the radius of this total length, we can pick the length, which is 0.2342. L equal to 0.2342, and which is the total length and spacing. So if we taking this value and save, then if we want to generate optimum frequency with them, and then we have putting the length and start the spacing and variables detect effect on parameter, and after optimization we put the value in update, and then we have to simulate at it resonance frequency sweep, and then after running this we can see we have the frequency, impedance range and 250, but there is no more change which should be which is not changed for this antenna. That means you can only change the you can only match the resonance frequency with the operating frequency in dipole antenna to design a dipole antenna or design a dipole antenna over the ground, this type of parameter. So you cannot design a parameter with in the time of you cannot match this parameter of resonance frequency to optimum frequency at the same time. It's the information you have to understand, and you can see the radiation pattern, which is if we want to change the frequency to, sorry, I have made a mistake, which is the length is 2342. Is that my mistake maybe? So if we save that and opening the start optimizer option to set the length and start the simulation, is that effect on the parameter. Sorry, to see that you have to open that and the frequency sweep and then generate, and to with the frequency range. Here if we see the impedance matching, we can see that there is the frequency range. No, there is no change in resonance frequency with the optimum frequency. So we have to understand that it's to match this frequency of resonance and the optimum or operating frequency, it should be on dipole antenna or dipole antenna over the ground, or monopole antenna. It should not be work on the helix antenna. So you should understand and try to enrich your knowledge by exercise and practice them, or work as my pattern follow. You can easily understand or evaluate the variation of this design. So thank you for this time, and next I will show you the different type of other antennas, and in the experimental work we are designing helix Yagyuda antenna, and in the experimental view we are putting the value of the parameter, and you can easily understand how to get the values and edit the values with their optimal frequency, and with work with their variable parameter. So thank you, that's for now.